So hello everyone. So today I'm going to be talking about displacement and the differences between displacement and distance. First and foremost, please go back to the previous videos where I talked about vectors and how we add them together and what they are they like real, and all the examples and everything. And then after this, I'm basically, after we're done with those, but after you get to know what's going on with vectors, then we're gonna go towards displacement. So okay, so in order to figure out what displacement is about, is what I'm trying, basically I want you to think about what displacement means in real life. Obviously, and you know, if we think about our everyday life experiences with the word itself, displacement, we always think about, well, I displace my back from this position to the other position, and that's basically what how we use displacement in on a daily basis, let's say. And in physics, indeed, we have actually the same sort of definition for physics for displacement in physics. So displacement in physics is basically where we start off with and where we end up being, and then that's it. And then I don't care how I went about this point A to point B, but what matters is where is point A, where is point B, and then I just draw a line, and the length of the line gives me the length of the arrow, gives me the size of the displacement vector, and also the direction of my arrow tells me whether I've displaced myself or the object from point A to point B, or from point B to point A. So this arrow means from A to B, this arrow means from B to A. So essentially what happens is, displacement, as you can very very vividly see, displacement is a vector quantity. Since it is a vector quantity, it has a length, a magnitude, which is given by the length of the arrow, and it has a direction, which is basically the tiltation of this arrow. So knowing this, and basically getting to know to know that displacement is actually a vector quantity, we can now see how different displacements are added together, because we are already explained in the other previous videos how we add vectors together. So that's that. That's as easy as it can get. Now we can, if we have like bunch of displacement, where let's say I have my bag sitting on here, and here is point A, then I displace my bag from this position to this position. So this is a displacement vector. Let's call this vector 1, and let's call it vector little a, and then I have my bag over here. So then I decide to displace my bag to here, let's say. So, and now what happens is, basically I have it at point C, so this is gonna be from here to here, this is gonna be my B, and then the resultant is from where I started off with to where my bag ended up being. So this is going to be the resultant of A and B. So R is A plus B. So that we already talked about in videos where I talked about vectors. But here now in this video, I'm trying to get you to idea of what is the differences between displacement and distance. Distance is more of a daily life experience kind of quantity. Distance is something that we, on a daily life basis, we are concerned with. Distance is something that Google Maps gives us. Let's say we are having to two locations on Google Map. We put in Los Angeles, we put in New York here, and then Google Maps probably gives us like a wrinkly line from on how we can go from A to from Los Angeles to New York. So what we are concerned with in our everyday life is basically how we go from point 1 to point 2. Displacement doesn't really care about that. In this example, displacement of LA and New York is simply this. So, excuse me, this is displacement, and this wiggly line over here, this is distance. All right, so make sure you can dissociate displacement with distance. So if I go to New York and then I come back after a week, then within that week my displacement is dead zero, because I started off in Los Angeles. After 1 week, if someone calls me at my house in Los Angeles, I'm gonna pick up the phone, so that person has no idea where I was before. So it's as if my displacement is dead zero. However, the distance is double this amount because I went to New York and came back. So make sure you basically distinguish between the meaning of displacement and distance. Distance is obviously all this pathway is taken into account. Distance is something that we are concerned with, because when we put like 2 locations on Google Maps, we want to see what is the closest or the fastest, like easiest way we can go from point A to point B. So that all depends on distance, whereas displacement is basically, to be very honest with you, it's like it's a jargon. It's like a physical quantity. It's something that we're gonna make the most out of when I'm gonna be introducing velocity to you guys. So keep this in mind, and the fact that this is a vector, this is not a vector. This all only basically cares about the starting point and the finish and the end point. Whereas distance, for distance, it matters how you go about things. Okay, so that's pretty much it in terms of addition of displacement vectors. Please go check the videos that I had on vector addition. Everything is on there. If you have any questions, please comment it down below. Please share it to anyone you think they're stuck with physics. I'm a physicist, so if you have any questions, please feel absolutely free to basically comment it down below, or you can, if you have like a snapshot of your question, you can take a snapshot and upload it on my fan page. I'll link everything down below so that you get to see what Facebook page I'm talking about and all that. I can respond to those questions as well. Feel free to interact with me in any shape or form. As long as it's physics and questions and academics, I'm all in. All right, I'll take care, you guys, and I'll see you guys very soon in the next video. Bye bye.